Kinetic friction, you know, kinetic friction, what is the value? It is fixed, mu kn, always mu kn. Okay, kinetic friction is always mu kn. So we will do more questions on inclined plane. Okay, we'll do inclined plane. Then after that, we have very important topic, that is block on block. Okay, two blocks. So first let's finish this inclined plane. Then after that, block on block. See, before rough inclined plane, you have to understand smooth inclined plane. Correct. So suppose a smooth inclined plane is there. Suppose theta. Now this is smooth inclined plane. Only one force is acting along the plane. Tell me what is that force if it is released? Mg sin component, correct, sin theta. Very good. So if you release it like this, acceleration will be g sin theta, it will slide, correct. If I ask, suppose I don't want this block to slide, I do not want this block to slide, I have to hold it, I have to hold like this. Like for example, this object, mg is acting downward, but I don't want it to fall, so I have to exert some force. What force I am exerting? Mg, very good. So I am exerting Mg force, okay, equal and opposite. Now I want to keep it at rest. So what force I have to exert up the plane? Mg sin theta, very good. So to keep it at rest, F is equal to Mg sin theta minimum. This is the minimum value of this force. Minimum must act up the plane. If it is more than, if F is more than this, what happens? It will accelerate, correct? Good. If F is greater than mg sin theta, so block accelerate, block accelerate. So how to find acceleration? F minus mg sin theta is equal to m, right? If F is more than mg sin theta, if F is equal to mg sin theta, it will be at rest, okay, or move with constant velocity. To keep it at rest or uniform motion, also balanced forces. To keep it at rest or uniform motion, mg sin theta, F, both are equal. Okay, fine. Okay, what if F is less than mg sin theta then? If mg sin theta is greater, then accelerate downwards. Very good. So if mg sin theta is less than F, so mg sin theta minus F is equal to ma. So acceleration will be down the plane. Acceleration will be down the plane. Okay. So first you understand these logics. Okay, where it will go? It will go or not? If it is going, where? Like this object. If I lose it, it is falling. So what is the acceleration? G. Acceleration is G. Now what is the acceleration? 0. My force is mg. If my force is greater than mg, it will accelerate up. Correct? It is accelerating up. So I am exerting more than mg. And now I am exerting less than mg because it is falling down. Correct? So whichever force is greater, it will accelerate there. Now, this is a smooth one. When it is rough inclined plane, you have to consider friction. So suppose this is the inclined plane. This is the block. First of all, angle of repose we have discussed. If theta is small theta is there. So down the plane, what force is acting? Mg sin theta. And up the plane, what force will act? Friction. Correct. If theta is small, so block at rest. Block at rest. Because when theta is small, mg sin theta is small. If mg sin theta is small, so friction is also small. Correct? Because we know that friction, static friction, minimum value 0, maximum value mu Sn. So, for example, we have discussed this. Suppose let's take theta is equal to 37 degrees. So what is tan theta? 3 by 4 means 0.75, correct? And suppose I am giving mu s, mu s is equal to 0.6, mu s is equal to 0.6. So this block will slide or not? Block will slide or not? What is the condition that the block will slide if you put it here? Correct. So right now it will slide or not? Yes, it will slide. Correct. Because tan theta is more. If tan theta is more than mu s, it will slide. Correct. Suppose if I give mu s is equal to 0.6, sorry, 0.6 no, 0.8. 0.8 if I give. Mu s is equal to 0.8. Now tan theta is 0.75, it is less than mu s. So it will slide or not? So not slide. It will not slide. Correct? So that is known as angle of repose. Tan inverse mu s is known as angle of repose. Okay, so that is a boundary. So that is a boundary. Angle of repose is a boundary. When tan theta is equal to mu s, tan theta is equal to mu s, I am calling it tan theta r. This is tan theta r. So what is theta r here? Angle of repose. Theta r is what? Angle of repose. Repose. What is angle of repose? What is angle of repose? Give me copy, register, one register, this. Okay. Pen, any pen. Okay. What is the angle now? Okay. Right now angle is 0. It is not sliding. Now angle is increasing. Angle is increasing. Okay, 30 degree, maybe 25 degree. At one particular angle sliding. See, increasing, not sliding, now sliding. Understood? So at what angle it will slide? That is known as angle of repose. So note down. If theta increases from 0 degree onwards, if theta increases from 0 degree at one particular angle, block slides. At one particular angle, block slides. Okay, that angle is known as angle of repose. First you understand this. Okay. Now What if angle is more than angle of repose? 100% it will slide. Now angle is more than angle of repose. Suppose angle of repose is 45 degree. Let, for example, let angle of repose is 45 degree. So if it is less than 45, if it is less than 45, it will slide or not? It will not slide. If it is more than 45, it is sliding, correct? It is sliding. At 45, it will not slide. At 45, this angle is 45. After 45, it is sliding. When angle is more than 45, it is sliding, correct? So that is angle of repose. So see, now we will do some questions. If theta is more than theta r, angle is more than theta r, it will slide or not? Slide. So it will slide, but I do not want to slide it. So find minimum additional force must be acting up the plane. Acting up the plane to stop. I want to stop it. What minimum force is needed? That is a question. Now angle is theta. So now you tell mg sin theta is acting down. Friction is acting where? Friction is acting up. If I release it, it is sliding. If I release, because angle is more than repose angle, so it is sliding, correct? But I want to keep it at rest. Okay, who is stopping it from sliding? Friction. But friction is not sufficient here, because mg sin theta is already greater than mu mg cos theta, correct? What is the maximum value of static friction? Mu s n. Mu s n. So mg sin theta is already greater than mu mg cos theta, correct? Tan theta is already greater than mu s. So friction tried its best. Friction tried its best to stop it. Friction tried its best to stop it. Friction tried its best to stop it, but cannot stop it, because this condition is there. Okay, so that's why it is sliding. Okay, so friction is there, acting, but not sufficient to stop it. So you have to exert some minimum force. Like for example, at suppose at 30 degree it is sliding, not sliding, not sliding, not now 30 degree it is sliding, correct? It is sliding at 30 degree, but I want to stop it. So you have to exert some force like this. Like this you have to exert force. Now it is not, now any angle it is not sliding. See, if I release my force, it will slide. So up the plane, what force you are exerting? So capital F, not down, capital F, or you can call it F1 also. Capital F or F1, anything you can write. So now you tell. Now it is at rest. So what is the relation? It is at rest. So F plus F1 is equal to mg sin theta. So what is F1? Mg sin theta minus F. So when I want minimum value of this, minimum additional force. So this is minimum when friction is maximum. Like for example, 5 can be written as 10 minus 5, correct or not? 4 can be written as 10 minus 6. So when this is maximum, when this number is more, this number is less, correct? 3 can be written as 10 minus 7. So this is minimum when this is maximum. So tell me, what is the minimum value of this f1? Mg sin theta minus mu s mg cos theta. Okay, so this is the answer. Note down. Mg sin theta minus mu mg cos theta. In your formula diary also you write this. What minimum force is needed to stop it? So mg sin theta is pulling down, friction is acting up, but friction not sufficient. Friction tried its best to stop. Okay, so you have to exert some force. Correct? You have to exert some force. Clear? So this is the formula. You write in formula diary also. Very important it is. Okay, and keep revising. Okay, I am not saying memorize it. Keep revising. Keep revising these type of questions. You will understand it, and you will memorize also. Okay, next question. So mg into sin theta minus mu cos theta. Okay, next. Theta is less than theta r. It will slide or not? Tell me. No slide. Correct. Block do not slide. Now question is, find minimum force down the plane. Read the question carefully. Okay. See, whether it is any subject, you have to read the question carefully. There is no fixed answer. If question slightly different, answer will change. In the previous question, what I gave? Minimum question up the plane or down the plane? Up the plane. So what is the minimum force up the plane? Okay. Minimum force acting up the plane. Observe it. Okay. Now next question, what I am asking, minimum force down the plane. Find minimum force down the plane. Block is not sliding. See, block is not sliding. So this object is not sliding, but I want it to slide. So you have to exert force like this. Understood? So you have to exert force. So down the plane. This is down the plane, this is up the plane. So what force you exert? Find minimum force down the plane so that it slide. To slide it. Minimum force. Minimum force. So down the plane, what is the force? Mg sin theta. Up the plane, what is the force? Friction. When it is not sliding, what is the friction value? Mg sin theta. Correct, very good. When not sliding, F is mg sin theta. But now I want to slide it. So you are exerting force like this. So this is the additional force. This is the additional force. Now it is sliding, it is just sliding, like this. So friction will be maximum static friction, note down. So friction will be maximum static friction. So what is the value of maximum static friction? Mu Sn. Okay, so note down. So this is equal to this plus this. So mu Sn is equal to capital F. You can call it F2. You can call it F2. Okay. So F2 because it is second question. Second question means F2. So F2 plus mg sin theta. So F2 is equal to mu Sn minus mg sin theta. So mu s mg cos theta minus mg sin theta. So mg common, mu cos theta minus sin theta. Note down. So in the first question, I want the block to stop from sliding. In the first question, I want block to stop from sliding. So minimum force you are exerting up the plane. Minimum force you are exerting up the plane. Okay, to stop from sliding. Now here theta is less than theta. So block do not slide. Block do not slide. Not slide. You are exerting force like this. Down the plane. So minimum force down the plane. Understood? What is the formula? Mg common. So mu cos theta minus sin theta. Mu cos theta minus sin theta. Yes. F2 is equal to this value. Correct. Minimum force needed. See, friction when F2 is not acting, friction is acting up the plane, mg sin theta is acting down the plane. Now block is not moving. The block is not moving. Correct? Block is not moving. How much is friction? Mg sin theta. Correct? But now I am exerting F2. I want to move it. So when you are exerting down the when you are exerting F2, this friction will increase. Okay, friction will increase. So you will also increase F2. F2 also increase. Then friction maximum value. We know that mu Sn. So what should be the minimum force needed? Suppose I am telling one example. Suppose mg sin theta is 6. Mg sin theta is 6. So friction is also 6. So not moving. But I want to move it. So you are exerting 1 Newton suppose. So friction will also becomes additional 1 Newton. So what is the new value of friction? 7. But still block not moving. So you make it 2 Newton. So what is the value of friction? 6 plus 2, 8 Newton. Okay. But 8 is the maximum value of friction. Suppose maximum value of friction is 8. So slightly more if you exert 2.1 Newton. If you exert 2.1 Newton, what will happen? Block will move, it will slide. Okay. So how you are finding this 2 Newton? How you are finding this 2 Newton? 8 minus 6. Maximum friction minus mg sin theta. Correct? So this is the answer. Note down. So minimum force down the plane to slide. Okay, you can solve this question now. One numerical I am giving. Suppose 37 degrees there, and mu s I am giving mu s 0.6. Mu s is 0.6, and mass is 1 kg. Mass is 1 kg. Okay. First you tell it will slide or not. It will slide or not. So that is the first step. You have to think. Okay. Check. You have to check. Okay. Check it slide or not. Okay. So this is the logic. We say no, logic is needed. So this type of logic you have to check it will slide or not. So what is the condition to slide? What is the condition to slide? Tan theta. Very good. Tan theta is greater than mu s. Not slide. What is the condition for not slide? Okay, so tan theta is less than or equal to mu s. Equal to mu s also not slide. Tan theta equal to mu s also not slide. Okay, so what is tan 37 here? 3 by 4. Okay, these are calculation. So 0.75. So this is tan theta is more here. So it is sliding. Okay. Now the question is, find minimum force up the plane. Find minimum force up the plane to keep it at rest. To keep it at rest. Okay. Find minimum force up the plane to keep it at rest. Okay, solve. Numerical. You can use F1 formula. What is F1 formula? mg common. What is the formula? Sin theta minus mu cos theta. Okay, use it. So 1 into 10 sin 37 3 by 5 minus 0.6 into cos 37 4 by 5, correct? So this is 10 into, now you can solve this 0.6 3 by 5 and this is 2.4 by 5 2.4 by 5, what is how much? 2.4 by 5 0.48, right? Are you getting? 0.48. So 10 into 0.6 minus 0.48, 0.12. Okay, you can solve like this: 0.60 minus 0.48. Which is greater, 0.6 or 0.48? 0.6. Okay, so 10 minus 8 to carry 1, so 5 minus 4. So 0.12 into 10. So what is the answer? 1.2. So answer is 1.2. Clear? 1.2. Are you getting or not? So first you understand. Understanding is also important. Just memorizing formula, it will help. If you just simply memorize this formula, it is good. Okay, it is good. If direct question comes like this, you directly use the direct formula. Okay, but you have to understand it also. First you have to check it is sliding or not. Okay, so okay, clear? Okay, done. So block is kept. It is sliding or not sliding? It is sliding or not? 1037.75 and mu s is 0.6, which is sliding. Minimum force up the plane to stop it, to keep it at rest. Stop it. Okay, it is sliding. So it is sliding. So I want to keep it at rest. Now I am exerting force. Understood? It is not sliding. So how much force I am exerting? How much force I am exerting? This much. Okay. So next you write down. Any doubt? Any question? Any problem? Tell me. Clear? Okay. Okay. Now next I want to slide it up. Now you solve. This is third question. Find minimum force to slide it up. Now I want to slide it up. If you want to slide it up, friction will act where? Suppose I want to slide it up. I want to slide it up like this. So friction is acting where? Down the, correct. So down the plane. So friction is acting down the plane. So that this is more important now. In previous two question, friction is acting where? In previous two question, friction upward, correct. Friction is acting upward. Okay, understood? You can check. This is question 1. Friction is acting up. Okay, question 2 also friction acting up. Friction is acting up, question 2. Now you have third question. Find minimum force to slide it up. Find minimum force to slide it up. So first thing you notice, friction will act down. Okay. Now friction act down the plane. Now friction will act down the plane. Okay. Suppose this is the block. So now you can call F3. So minimum force, find minimum force to slide it up. Okay. So F3. Now friction will act down the plane, mg sin theta will act down the plane. Understood? So minimum, I just want minimum force, so you can balance it. So F3 is equal to F plus mg sin theta. Okay, clear? So what is the answer? Tell me. I want minimum force. So friction will try its best. Friction will try its best to stop it. Okay, friction try its best to stop it. I want to move it up. I want the block to slide up. So mg sin theta is down, friction is also down. Friction will try its best. So what is the maximum value of friction? It is acting now. Mu s n, correct, very good. So when this is minimum, this is maximum. Okay, friction is maximum. Okay, you have to understand this, because I want block to move up. So friction will act down, and friction maximum will be there, maximum friction. So answer is mu s n plus mg sin theta. So mu s mg cos theta plus mg sin theta. Okay, clear? So this is the answer, total. So mg common, mu cos theta plus sin theta. So you can remember this question now. What is the first question? To stop it from sliding. What is the formula for first question? To stop it from sliding. To stop it from sliding. Minus mu cos theta. Very good. To stop it from sliding. What is the second question? F2 is to slide it down, correct? F2 means to slide it down. It is not sliding, you want to slide it. This is F2. You are not, it is not sliding. You want to slide it like this. So what minimum force is needed? Tell me. mu cos theta minus sin theta. Correct, good. Now you want to slide it up, F3. What is the formula? You want to slide it up. Mu cos theta plus sin theta. Correct. Mu cos theta plus sin. Okay. This is the formula just stop from sliding down. This is to make it slide down, to slide it down, okay, to slide it down, and this is to slide it up, to slide it up. Okay, fine, to slide it up. So these three formula you remember, fine. Okay, very important. So next, so inclined plane over, let's keep it. Okay, maybe after November, December we'll solve more questions, okay, on inclined plane. You practice it, okay. So whatever book you have, Singage, Arihant, Errorless, okay, MTG, Disha, NCRT, okay, you practice, okay, inclined plane you practice. Inclined plane you practice. So, okay, take this. Inclined plane you practice. Okay. Now, next topic you write down block on block. First you will consider two blocks. Okay, two blocks you write down. Two blocks and wall. It is easy to understand. It is very easy. Okay, it is very easy topic. Two blocks and wall. Okay, this is friction topic. Still we are doing friction only. Okay, friction. Two blocks and wall. So see, two blocks and wall. One block we have discussed. Okay, I am revising one block. One block you have seen. Suppose this is one block. Okay, one block is there. So, like for example, any boxes there? You give any copy, you give any copy. Register, any register. This is okay, no problem. Okay. So it is sliding, right? What I have to exert? Force, horizontal force. If I don't exert horizontal force, falling, correct? So what minimum force is needed to stop it? We have discussed this. What is the minimum force needed to stop it? Tell me. What is the downward force? Mg. Now friction will act up, and this is capital F, right side. Small f means friction, okay. A normal left. So to stop it from sliding, what is the minimum force? Tell me. Mg must be less than or equal to mu Sn, correct? What is the maximum value of friction, static friction? Mu Sn. And what is the pulling force here? Why it is falling? Why it is falling? Why it is falling? Mg. Because of Mg it is falling, correct? To stop it from sliding, what is the condition? Mg must be less than or equal to mu Sn. And what is N? F. So Mg must be less than or equal to mu S F. So Mg by mu S must be less than or equal to F. So now you write like this, like 2 is less than 3. So 3 is greater than 2. Like this you write. Write F here, this here. What you write? Tell me. F. greater than equal to mg by mu. Okay, so this is the formula, note down. F greater than mg by mu. This we already discussed this. Okay, I am revising. This is just revision. Okay, clear? Mg by mu. For example, you have block of mass 3 kg and mu s is 0.4. Mu s is 0.4. So how much minimum force is needed? How much minimum force is needed? Mg by mu. So 300 by 4. What is 300 by 4? 75. Okay. So 75 Newton is needed. Suppose mass of this object is 3 kg and it is rough surface, coefficient of static friction 0.4. Now I just want to stop it from sliding. So what forces I am exerting? 75 Newton. Okay, 75 Newton. Okay, done. So this is single block. One block is there. Clear? Okay. What if two blocks are there? See, let's do two blocks. Very carefully observe. This is M1. This is M2. Now you are exerting force capital F. Okay, like this. Now wall is rough and surface between M1 and M2 also rough. So coefficient of friction here is mu1 and coefficient of friction between M2 and M1 is mu2. Okay, mu depends on nature of surface. Okay, mu depends on nature of surface. Okay, so wall, this is wall and M1 it is mu1 and M2 M1 it is mu2. Okay, so first you understand the free body diagram. M2, capital F is acting right side and normal from M1 is acting left side. Let's call it N1. What is N1? Normal from M1. Like normal on M1 from wall will be left side. Normal on M2 from M1 will be left side. M2, okay. Mg downward. Now you tell what is the direction of friction here for M2? Tell me. Give me one more resistor. You give any give. I need or that boat. This no problem. This I will take. No problem. This. So this is one block. Now this is second block. Correct? Like this. Understood? This is the situation. Okay, tell me. Mg is acting downward. So friction is acting where? Upward. Very good. So let's call it F1, small f. Who is exerting this? M1. Very good. So this is friction on M2 exerted by M1. Exerted by M1. Okay, clear? This is clear, everyone? This diagram, any problem? Capital F you are exerting on M2, normal from M1, left. Friction from M1. Why friction is up? Tell me. Why friction is up? Why? Because weight. Where is weight? weight is down, so friction is up. Okay. Now come to M1. Mg downward, M1G downward. Okay. M1 exert normal on M2 left. So M2 exert normal on M1 right. Very good. So this is N1. This F not acting on M1. Okay. F is acting on what? M2. So this F is not acting on M1. What is acting on M1? Normal. Normal is acting. Wall will exert one normal. It is N2. So first you understand what is N1 and N2. So this is from M1 and this is from wall. Okay, understood? Normal from wall, normal from M1. So action reaction. This is action. This is reaction. Action is acting on M2. Reaction acting on M1. Okay. M1 exert friction on M2 up. So M2 exert friction on M1 down. So draw. This is F1. This is friction exerted by M2. So friction exerted by M2. See, friction is real force or pseudo force? Friction. Real force. So it will follow third law. Friction also follows third law. Friction also follows third law. We have example for this. In winter, if you are feeling cold in winter, what you do? You do like this, correct? You do like this. Why? In winter you do like this. Why? Very cold. Suppose you are doing like this. Now this upper hand, lower hand. Okay. What is direction of friction on upper hand? Right side. Very good. Because with respect to this, it is going where? Left side. So friction on this is where? Right side. Now what is friction on this? Left side. Correct. See, with respect to this, it is going where? Right side. So friction on this where? Left side. Okay. Action reaction. So with respect to M1, M2 is going down because of Mg. So friction on M2 is up. Okay. Now with respect to M2, okay, understood. So friction on M2 is up. So friction on M1 will be down. Who is exerting this F1? M2. Okay, clear? Now come here. Both these forces are acting where? Downward. So wall will exert friction on M1. Where? Upward. So this is F2. So this is friction from wall. Friction from wall. Okay, clear? No doubt. So friction from wall. So now what is the condition? So what is F1 value? Tell me. Suppose it is at rest. Blocks are at rest. So what is the condition? Tell me. What is F? N1. Correct. So N1 is equal to F and F1 is equal to M2G. F1 is equal to M2G. Similarly, you write here N2 and N1 equal. So N2 is equal to N1. And what is the relation in these three? What is the relation? F2 is equal to F1 plus M1. Note down. So copy this. two blocks. Okay, so maybe in NEET paper they can ask this type of question, like this is the situation, direction only they can ask, only direction. The friction on M2 due to M1 is up, friction on M2 due to M1 is down. Okay, options I am giving. What current, oh, okay,